In this video, we're going to take a look at the function f of x is equal to 27x minus x to the third, and we're going to see if we can find the intervals on which f is both increasing or decreasing. So, increasing and decreasing is a behavior of the first derivative, it's a behavior of slope. We know that a function is increasing when its slope is positive, it's decreasing when its slope is negative. So we're going to be looking essentially for three things. We're going to be looking for places where the derivative is zero. We're going to be looking for places where the derivative is undefined, and we're going to be looking for values of x that are not in the domain of the function. Those will give us three different types of places where a function can change from increasing to decreasing. In between any consecutive pair of those three things, the function must remain increasing all the time or decreasing all the time. So let's consider f prime of x is equal to 27 minus 3x squared. Now that can't be undefined. That's going to be defined for all values of x. So we only need to consider zeros. So 0 is equal to 27 minus 3x squared. And if I simplify that a little bit, I should find that x squared is equal to 9. Divide everything by 3 and then add an x squared to one side. If we take square roots on both sides, we'll pick up x is equal to plus or minus 3. Don't forget the plus or minus when you take square roots on both sides of an equation. Negative 3 squared is positive 9, positive 3 squared is positive 9. Both work, they're both solutions. Once we have this information, we'll create a sign chart. This function goes to infinity in both directions, and we have a negative 3 and a plus 3 for our critical numbers here. No points that aren't in the domain of this. This is a polynomial function, so its domain is all real numbers, so this is all we have to worry about. What we need to do is test the first derivative at some test values in each of the three intervals we end up here. And we'll try to choose the smallest and easiest ones that we can. So looking at f prime, we want to plug in negative 4 first and see what happens. And we don't care a lot about the number. All we really care about is its sign. We know that if the first derivative is negative, then the function is going to be decreasing on this interval. If the first derivative is positive, we're going to be increasing on this interval. So if I plug negative 4 into x, I'm going to get a positive 16 times 3, that's 48. 27 minus 48, that's definitely a negative number. So I'm decreasing here. When I plug in 0, I'm just going to end up with positive 27. Nice positive number. I'm increasing here. And when I plug in 4 and square it, I'm going to get 16 times 3 is 48. 27 minus 48 again. We're negative. So we're going to be decreasing. So this function is increasing on the intervals on the interval negative 3 to positive 3. And it is decreasing on the interval negative infinity to 3, as well as the interval 3 to positive infinity. Please make sure when answering these kinds of questions that you actually write out the intervals. Don't make somebody go looking for them. Don't make someone interpret your sign chart. You want to include the sign chart. That's a good chunk of showing your work, and I would like to see that on tests when you do these types of problems. But I'd like you to explicitly write out your answer. What are the intervals on which the function is increasing? What are the intervals on which the function is decreasing? And I'd like you to notice that those intervals are always going to be open intervals in our answers.